ME 8492 Kinematics of Machinery Unit 4 Gears and Gear Trains Tutorial Problem 3. Here in this tutorial problem you will see the problem about the minimum number of teeth on the pinion in order to avoid the interference and minimum number of teeth on the wheel in order to avoid the interference presented by TPG80 value 2. So minimum number of teeth on the pinion in order to avoid the interference. Okay, here AP equal to AP is nothing but addendum on pinion. Addendum on pinion equal to T divided by 2 into square root of 1 plus capital T divided by small t into capital T divided by small t plus 2 into sine square pi minus 1. Resolve this equation and now we will get T equal to 2 into P go up 2P divided by square root of 1 plus capital T divided by small t into capital T divided by small t plus 2 sine square pi minus 1. Here capital T is number of teeth on the pinion and small t is number of teeth on the capital T is equal to number of teeth on the gear wheel and small t is equal to number of teeth on the pinion and pi is the gear ratio, pi is the pressure angle of the gear tooth. Now G is here G is nothing but gear ratio. Gear ratio equal to T capital T divided by small t. Okay. Now we apply the value of G here. So small t equal to 2 AP divided by square root of 1 plus G into capital G plus 2 into sine square pi minus 1. This above equation gives the minimum number of teeth required on the pinion in order to avoid the interference. Uh, in previous tutorial, we will discuss about the interference. Okay, uh, the two basic things are used to avoid the interference of the gear, meshing gear wheels. Okay, two mating gears. The one thing is minimum number of, and second thing is already first thing is already discussed in previous video. Here this is the second method used to avoid the interference of the gear teeth. Okay, we will maintain the minimum number of teeth on the gear and pinion. We will avoid the interference of the gear wheel and undercut in the gear root or pinion root. Okay, uh, this is the formula for finding the minimum number of teeth on the pinion. Okay, in order to avoid the interference formula. Using this formula, we have to find the small t. So the small t is number of teeth on the pinion. Okay, here note. If the pinion wheel is have equal teeth, that means gear and pinion both are having the equal teeth. That means gear ratio is 1. Therefore, the above equation is reduced to here we will apply the value of G uh, because uh, because of the G we apply the value of 1. So we will get 1 plus 1 plus 2 3 sine squared pi minus 1. Okay, that means square root of 1 plus 3 sine squared pi minus 1. Okay, and then second one is the minimum number of teeth on the pinion which will mess with any gear, also rack and pinion also. Okay, rack and pinion gear animal also without interference are given in the following table. These are the minimum number of teeth on the pinion. Some standard data are given in this value. For the system of teeth, the four system of teeth are there. One is 14 and a half degree composite, and second one is 14 and a half degree full depth involute and 20 degree full depth involute and 20 degree sub involute. Okay, here the system of 14 and half degree composite system will use the 12 number of teeth in the pinion. For this second system of gear teeth, 14 and half degree full depth. 14 and half is nothing but pressure angle of the gear wheel. Full depth involute gear will use the minimum number of teeth is 32. For 20 degree full depth involute for using 18 number of teeth. Here 20 degree in sub stub involute system using 14 number of teeth. Okay, this is the some of the standard data. Okay, the next one is minimum number of teeth on the wheel. That is previous one is minimum number of teeth on the pinion. Here number of the teeth on wheel in order to avoid the interference. Wheel is nothing but gear. Okay. Here AW means addendum on wheel. AW equal to capital T divided by 2 into square root of 1 plus small t divided by capital T into small t divided by capital T plus 2 sin square pi minus 1. Okay. Reduce this equation. T equal to 2 AW divided by square root of 1 plus small t divided by capital T into small t divided by capital T plus 2 sin square pi minus 1. Here t divided by capital T divided by small t is equal to g. Now small t divided by capital T is nothing but 1 divided by g. Using this relation applied to this formula, we will get the value of minimum number of teeth on the wheel in order to avoid the interference. Capital T equal to 2AW divided by square root of 1 plus 1 divided by g into 1 divided by g plus 2 into sin squared pi minus 1. Okay. Note, from above equation we may also obtain the minimum number of teeth on the pinion. From this equation we have to obtain the minimum number of teeth on the pinion also. Okay. For that we will multiply both sides by small t divided by capital T. Okay, apply both sides small t divided by capital T, and now we get small t value. Small t equal to capital A, say 2AW divided by G into 1 plus 1 divided by G into 1 by G. Here T by small t by capital T is nothing but 1 by G. So we'll small t. Okay, this is 1 by G. So this 1 by G is coming to denomination. Now we get capital G into square root of 1 plus 1 divided by G into 1 by G plus 2 into side square by minus 1. And second one is if wheel and pinion have the equal teeth, G equal to 1, we will get 2AW divided by square root of 1 plus 3 sin squared by minus 1. Here we have to listen carefully. The square root is up to this sin squared by. Minus 1 is outside of the square root. Okay, we have to aware of this thing. Okay, before we go into solve the problem, you have to aware of this. Okay, in exam point of view, you may made the mistake from this area only. Okay, so you have to very aware of this. Okay, just go for the problem. Uh, a pair of 20-degree full depth involutes per gear having 30 and 50 teeth respectively of modulus 4 mm are in mesh. The smaller gear rotates at 1000 rpm. Here small gear is nothing but pinion. Pinion is rotating at 1000 rpm. N1 is equal to 1000 rpm. Determine the sliding velocity at engagement and at disengagement of the pair of teeth and contact ratio. Okay, both the things you have to find. Similarly, from the previous tutorial problems, other things you will find. Okay, sliding velocity of the engagement and disengagement, that is uh, omega 1 plus omega 2 into kp for disengagement pl. Okay, and the contact ratio is nothing but length of arc of contact divided by circumference pc, pitch circle diameter or circular pitch. Okay, using that relation you will find this value. Before that, uh, in previous tutorial 1 problems, and the addendum values they are given in this problem directly. If the addendum value is not given in this problem, we have to find the addendum value of value of the gear wheel using these relations. Using this relation, we have to find the addendum value of the gear wheel. Okay, here they are given uh, pressure angle is 20 degree and smaller t equal to 30 and capital T is 50 and model is 4 millimeter and number of teeth on the pinion is uh, sorry speed of the pinion is 1000 rpm. Using this relation, omega 1 equal to 2 by n divided by 60, 2 by n1 divided by 60. N1 is 1000. Apply this value in this formula and we will get the value of omega 1. Omega 1 is equal to 104.7 radians per second, and omega 2 divided by omega 1 equal to capital T divided by small t. Using that relation, you will find the omega 2 also. Okay, we'll find later on. Now go for the solution. Okay, first one is sliding velocity at engagement and disengagement of the teeth. Okay, for engagement we have to find the kp value and kp length of path of approach, and for disengagement we have to find the length of path of research. Okay, for kp and pl value. Okay, for we have to find the kp and pl. Before that we have to find the value of capital R and small r, capital RA and small RA. Okay, let's solve the problem. First one is sliding velocity of the engagement and disengagement of the pair. Okay, first we will find the addendum value of the smaller gear. Okay, using this formula, m into small t divided by 2 into square root of 1 plus capital T divided by small t into capital T divided by small t plus 2 into sine squared by minus 1. Here the minus 1 is outside of the square root. Okay, you are aware. Okay, here only you may made the mistake at the point of exam. Okay, so you may aware of this area. Okay, now all the values we know. So module value already given. Module is 4 millimeter into smaller t is 30 and capital T is 50, and pi pressure angle is 20 degree. All the values substitute in this formula and we will get the value of addendum in smaller gear. That means smaller addendum, addendum of pinion value. Okay, similarly you will find the larger gear. Okay, find the value of addendum value of the gear using this relation. Small m into capital T divided by 2 into square root of 1 plus t small t divided by capital T into small t divided by capital T plus 2 into sine squared by minus 1. Okay, already we know all the values and all the values substitute in this formula and solve this equation and we will get the value of addendum value of the gear is 9 millimeter. Now we found the value of addendum of gear and pinion, and now easily we find the small area and capital area and small R and capital R. Okay, let's see. Uh, Small r is pitch circle radius of the smaller gear. R equal to small r equal to m into t divided by 2, and we will apply the value. We know the values, module and smaller t value, and we will apply the values in this formula, and we will get the value of small r, and radius of the addendum circle of the smaller gear is Ra equal to r plus addendum of the smaller gear. Okay, we'll apply the value. What is the addendum of smaller gear is 18.6 plus what is the radius of the smaller gear is 60. Apply this value and we will get the RA. Similarly, we will find the capital RA and capital R. Okay. Now we will calculate the length of path of approach. It is a path of contact when engagement occurs. Okay. Kp equal to square root of Ra squared minus R squared cos squared phi minus R sin phi. Okay, we know all the values. Capital RA is 109 millimeter and capital R is 100 millimeter. Avoid these values, and what is the phi value is 20 degree. Apply all the values in this equation, and we will get the value of Kp. What is Kp value is 21 millimeter. Similarly, we will calculate the PL value, length of path of recess. Here, path of contact when the disengagement occurs. Okay, and what is PL value is 34.24 millimeter. Okay, then now calculate the area of sliding velocity at engagement of the pair of teeth and disengagement of the teeth. Okay, this is similar problem with uh, tutorial 1. Okay, here only thing we are different from that tutorial 1 problem. We are finding the value of addendum here. In last problem, in tutorial 1 problem, the addendum values already they are given in the formula itself. Sorry, problem itself. Here the addendum value is not given. So we are extra using this lesson, and you will find the addendum value of the gear and pinion here. Okay, that is the different from tutorial problem 1 and 3. Okay, otherwise other things are same. And it calculate the sliding velocity at the engagement. The engagement is nothing but Kp. Here omega 1 already we found. Okay, what is omega 1 is 104.7 radians per second, and omega 1 divided by omega 2 equal to capital T divided by small t. Using this relation, you will find the omega 2 value. Here omega 2 equal to omega 1 into small t divided by capital T. Okay, we know all the values omega 1 and small t and capital T. You can apply all the values and we will get the omega 2 value, and sliding velocity at the engagement of the pair of teeth omega 1 plus omega 2 into Kp. Okay, at the point of engagement, already why we are using Kp already discussed in the tutorial 1 problems using that diagram. We will discuss already. You go through that problem. Okay, omega 1 plus omega 2 into Kp. Now we get the value, apply all the values, and we will get the value of sliding velocity at the point of engagement is 3.518 meters per second. And second, the sliding velocity at disengagement of the pair of teeth is omega 1 plus omega 2 into PL. Okay, apply all these values and we will get the value of sliding velocity at the point of disengagement 5.736 meters per second. Okay, next, contact ratio. find the value of contact ratio. Uh, Contact ratio is nothing but length of arc of contact divided by pitch circle. Okay, circular pitch or pitch circle. Okay, for this we have to find the length of arc of contact. What is length of arc of contact? Is nothing but length of path of contact divided by cos phi. Okay, here length of path of contact KL equal to KP plus PL. Okay, already we found the KP and PL value are these two values and divided by cos 20 degree. Okay, now we get the value of arc of contact and circular pitch. Circular pitch is nothing but pi into m. Pi into m. Here m is the model of the gear wheel. Pi into m. Here circular pitch is 12.568 millimeter. Apply this both value in this formula contact ratio. We'll get the value of contact ratio is 4.67 says 5. 5 teeth are contact in position. Okay. Uh, okay. This is a simple problem and let's go for the second problem. Okay. The second problem. Uh, Two gear wheels mesh externally and are to give a velocity ratio of 3 to 1. The velocity ratio is 3. Okay, capital G is equal to 3. The teeth are of involute form. Okay, here we all the problems we are discussing about the involute form only. Okay, the two forms of gear forms are there. One is involute form and second one is cycloidal form. Mostly we are using involute only. Okay, because of that all the problems coming under the involute form. Okay, the model is equal to 6 millimeter. Addendum is equal to 1 model. Okay, that means addendum is equal to 6 millimeter. In this problem, addendum are given. Next, pressure angle is equal to 20 degree. The pinion rotates at 90 rpm. Okay, determine the number of teeth on the pinion to avoid the interference on it and the corresponding number of teeth on the wheel. Okay. Uh, okay. Here number of teeth on the gear and number of teeth on the pinion not given. Okay, using the previous minimum number of teeth on and the pinion and wheel avoid the interference formula. uh, you have to find the number of teeth on the pinion and the gear wheel. Okay, capital T and small t value you have to find first, and second one is the length of path of contact and arc of contact, the number of pair of the teeth in contact, that means contact ratio, number of pair of the teeth in contact or contact ratio. Okay, both are same. Next, maximum velocity of sliding. Okay, the second, third and fourth question already we discussed. These are the you may know and well known things. Okay, and the first question only new from the previous problem. Okay, uh, now you have to find the number of teeth on the pinion to avoid the interference on the pinion corresponding to the wheel. Okay, what are the data they are given? One is gear ratio, capital T divided by small t equal to 3, and second one is model M equal to 6 and AP and AW. Addendum of pinion and addendum of wheel equal to 1 model, that means uh, 6 millimeter. Okay, addendum value here compared to previous problem. In that problem they are given capital T and small t value and they were not given the addendum value. For this problem they are given the addendum value and they are not given small t and capital T value. Okay, uh, uh, same thing only, using that relation you have to find here the small t and capital T. Okay, not a big deal. Okay, simple only. Okay, and pi equal to 20 degree, and n on number of speed of the pinion is 90 rpm. Using this value, we'll get the omega 1 2 by n1 divided by 60. Here n1 is 90. We'll get the value of omega 1 equal to 9.43 radians per second, and omega 1 divided by omega 2 equal to capital T divided by small t. Using that relation, we will find the omega 1, sorry, omega 2. I will find the later. Okay, I'll go to solve the problem. First one is number of teeth on the pinion to avoid the interference uh, on it, and the corresponding number of teeth on the wheel. Okay, using this relation, the we know that number of teeth on the pinion to avoid the interference. Okay, this formula already we discussed it. What is that formula? Okay, this formula, or else using this formula. Okay, 2ap divided by 1 plus g into g plus 2 sin squared by minus 1. Using this equation, using this formula, we will find the value of small t. Okay, and G, capital G equal to capital T divided by small t equal to 3. Already gear ratio they are given. Using that relation, we will find the capital T value. Okay, simple only. Okay, small t equal to 2ap divided by square root of 1 plus capital G into G plus 2 into sin squared by minus 1. The minus 1 is outside of the square root. Okay. Now we know G already given in this question. G equal to 3, and AP equal to AP and AW equal to 6 millimeter, and pi value is 20 degree. Yeah? Yes, 20 degree. Yes, pi is 20 degree. Apply all those value into this formula. We will get the value of small t. Here 18.2, it is cross the 18th value, 18.1, 18.2, 18.05. Suppose you get the value of 18.05, you go for the next value 19. Okay, now you say the 18.2, get the minimum number of teeth uh, to avoid the interference is 19 teeth. Okay, correspondingly number of teeth on the wheel. Using this relation, G equal to capital T divided by small t. Now capital T equal to G into small t. Here G is 3. Gear ratio is 3 into 19. We will get the number of teeth on the wheel is 57. Okay, this thing only newer from previous problem. Other things are already we discussed in previous problem, so no problem. Okay, second thing is length of path and arc of conduct. Here you have to find the length of path of conduct. Path of conduct is equal to KL. KL equal to KP plus PL. You'll find the KP and the PL. You have to find the value of small r and capital R, small ra and capital RA. Using this relation, you will find the small ra, small r and small ra. Similarly, capital R and capital RA. Okay, the small r is 57 millimeter. Small RA is equal to 63 millimeter. Capital R equal to 171 millimeter, and capital RA equal to 177 millimeter. Okay. Now we'll find the length of path of approach. It is path of conduct when engagement occurs. Kp equal to square root of, here also the square root is up to here. The minus r sin phi is the outside of the square root. You have to aware of this. Okay, the square root of r a square minus r squared cos squared phi minus r into sin phi. Apply all those values in this equation. we will get the value of Kp equal to 15.7 millimeter. Now similarly, find the length of path of research. PL equal to square root of RA squared minus R squared cos squared pi minus R sin pi. Okay. Apply all these values into this formula and we'll get the value of PL. Okay. Now add the PL and Kp value and we get the value of KL, length of path of contact. Here the length of path of contact is 29.37. Now arc of contact, length of arc of contact equal to length of path of contact divided by cos phi. Okay, 29.37 divided by cos 20 degree, and we will get the value of length of arc of contact. Arc of contact is 31.25 millimeter. Okay, next one is number of pair of teeth in contact. Number of pair of teeth in contact is nothing but contact ratio. Contact ratio is also called as number of pair of teeth in contact. Okay, contact ratio equal to length of arc of contact divided by PC. PC is equal to pitch circle or circular pitch. Circular pitch is nothing but pi into m. Here m is 6, module is 6. So we will get the value of PC. PC equal to 18.825 millimeter. Apply both the values into this formula and we will get the value of contact ratio. Here the contact ratio is 1.66. That means two gears are mating in contact. Okay. Next one is maximum velocity of sliding. Here you have to find the maximum velocity. Already we found the value of omega 1. Using this lesson, you will find the omega 2. Omega 1 divided by omega 2 equal to capital T divided by small t. Okay, already we found the omega 1 value is 9.43. Apply the value in this lesson. We'll get the value of omega 2. Omega 2 equal to 3.14 radians per second. Now we find the maximum velocity. Here Vs equal to Kp, sorry, omega 1 plus omega 2. Here Kp. Why? Because using Kp is greater than Pn. Okay. Here they are asking maximum velocity. This greater value only multiply here. Okay. Comparatively Kp and Pl in both this value, which is greater value, that value only we will apply here. Suppose they have to ask minimum velocity of shading, means we have to apply the smaller value into this formula. Okay. Vs equal to omega 1 plus omega 2 into Kp. Here omega 1 is equal to 9.43 and omega 2 is 3.14 and Kp value is 15.7. And solve this value, we will get the value of 197.35 millimeters per second. Okay. Thank you, students. I hope you understand tutorial 3 problems. That's all. From this, the gear portions are completed up to this problem only. And second part is gear ratio. In fourth unit, up to this tutorial, first of the gear portion is completed. Okay. Thank you, student. I hope you understand all these two problems. We are using this interference minimum number of teeth used in gears. Okay, that interference formulas. Uh, if you have any doubt, ask in comment box, comment section. I will give you the reply. Okay, thank you so much.